We're going to continue our discussion of the Pythagorean theorem. We've looked at how the theorem works and finding a leg or the hypotenuse. We've also looked at the converse of the Pythagorean theorem, which works for non-right triangles and determining if a triangle is right or if it's obtuse or acute. But what we're going to do is go back to this idea of the right triangle and what Pythagoras had, and to find the distance between 2 points. So let's remember Pythagoras' theorem. It was about right triangles, and it stated that if you took squares off the sides of the triangles, that you could add them together to get that third square. Now, you could kind of see over here on the legs that this kind of follows the pattern of a coordinate plane. But when we look at the hypotenuse, how it comes at an angle, it really doesn't follow the coordinate plane anymore. So it would be very difficult for us to do this measurement on a normal coordinate plane. So that's where the Pythagorean theorem will come in and help us. So let's take a look at a triangle on the plane. And here we have a triangle in the first quadrant. And what it's doing is giving us being able to get a value. And we can see from one point to another point, we can count 1, 2, 3, 4. So we can measure that this is 4. We can also see on the, and that's on the x, so we can also see on the y a measurement where we start in from the bottom to the top. We count 1, 2, 3, 4, 5. So we see this as a measurement of 5. But then what happens when we try to come across the hypotenuse? The hypotenuse doesn't follow a straight line. It isn't cutting through the boxes equally. Sometimes a tip, sometimes more than that. So because it's coming in at different angles, we need to apply the Pythagorean theorem. And this is how it would work for distance. We know that a squared plus b squared equals c squared. So that means that the sum of the squares, that if we were to build squares off to the sides here, the sums of these squares would be equal to the area of this third square. But if I was looking for just the hypotenuse, just this measurement of the hypotenuse, I would have to take the square root of this square, because a square root means the measurement of the side of a square. So when I do that, I end up with a squared plus b squared under the square root sign on the left, and just the c by itself, because the square root of c squared is c. It is the inverse operation of squaring something, taking the square root. Now you'll notice over here on the left that we still have that addition sign and that the square root is stuck underneath it, this a squared plus b squared. Well, because addition is not related to the square root at all, and it's a different function. So because of that, it will stay underneath, and we will follow the order of operations if we had numbers. But let's continue on and see with our exploration of finding c what it would mean. We know that this a squared really represents the change of x. It represents from one value to another value, and we saw that earlier on that first triangle. The same can be said then for b. b is also a measurement on the y-axis. If we subtract these two y values, we will get a value and be able to plug it into b squared. So if we take these two things, this x minus x and this y minus y, and substitute it into the equation itself and replace it, we end up with the square root of x minus x squared plus y minus y squared. And what that would give us is, once we finished it, it would give us a distance, the distance of c, because what we're looking for is this distance here along this line. So what we're going to do is use this formula to find our distances. So let's take a look at a couple of problems and different situations that we would use the Pythagorean theorem to find distance on a coordinate plane. Well, here we have an example 1, 2 points. And what we should be able to look for when we see points is looking for that right triangle. So I'm going to draw a right triangle here for us. And we can see this right angle. And we can take measurements. We can see that along the x-axis that it measures 3, and along the y-axis it also measures 3. But we don't know what it is through here, so what we're going to do is use the Pythagorean theorem to determine that measurement. So using that a squared plus b squared equals c squared idea, we're going to use the distance formula. So I know that this measurement here, the x's, because remember this is our formula, right? X minus x plus y minus y, and all of that's going to equal c. So we know just by measuring right now on this triangle that I have 3 squared and the y's are 3, so 3 squared, and that equals c. Then I will have the square root of 9 plus 9, which equals c. And then I'll have that it is the square root of 18. Normally you would be able to stop at this point, but sometimes we need to take it to the nearest tenth. We know that the square root of 18 is found between the numbers of 4 and 5. And if we were to use a calculator to find the square root of 18 and rounding it to the nearest hundredth, we would find out that that length, that distance along that triangle, that hypotenuse, is approximately 4 and 24 hundredths. So let's take a look at another problem and what we might do if we didn't have it on a coordinate plane, but we were just given points. Here we have 2 points, the first one being 3, negative 1, and the second one being 4, 0. Once again, we're going to use our Pythagorean Theorem distance formula, where we take the values of the x's and we're going to square them. We're going to add it to the values of the y's as we subtract them from each other to find that distance, and it's going to equal c. So let me move this down a little bit. So I want to talk about ordered pairs for a second. We know that in every ordered pair, the first value is x and the second value is y. So what we want to do is we want to keep the y's together and we want to keep the x's together so that we put them in the right place in this formula. So taking that square root, I take the values of the x's and I'm going to subtract that, so it's going to be 3 take away 4, and I'm going to square that value. And the y's would be negative 1 minus 0, and I would square that value, equaling c. We know that 3 take away 4 happens to be negative 1 squared, plus negative 1 minus 0 is also negative 1, and we're going to square that. Following just the order of operations, we did parentheses, now we're doing exponents. Negative 1 squared is 1, and the other one is also 1. And we get the square root of 2. We know, once again, that we could leave it in this format, but if we need to round it off and find it to the nearest tenth, we would find out that c was approximately 1 and 41 hundredths. That's the distance of that hypotenuse side when I have these points on a coordinate plane. So now we're going to take a look at a problem where there's a lot going on. So here on this particular problem, we're going to graph these points, we're going to find the distances, and we're going to use the theorem in order to do that. So let's first label these points. I'm going to call this point A, point B, and point C. I'm going to take point A and put it on the coordinate plane. There we go, point A. Point B is at negative 1, positive 1. There's point B. And point C is at 2, 3. I'm going to use some straight lines to connect this a little bit. So from here to here, and from here to here, and from there to there. Okay. So we have a triangle, and when we look at this triangle, we're going to look for 3 measurement sides. We're going to look for the side of AC. We're going to be looking for the side of BC. And we're also going to be looking for the side of AB. Now, when looking for these sides, the only one that we can measure straight out front is AC, because we can see it's a straight line and it measures 1, 2, 3, 4 boxes. So we know that this measurement happens to be 4. That's the only thing that we can find up straight away. So then what we're going to do is we're going to need to use these points. We're going to try to find B and C. Let's see if we can find these points here. This distance, because we can build a right triangle right here. Everybody see that? And I'm going to build a right triangle right there. And when I build this right triangle, I can see that it has a leg side measurement of 3 and another leg measurement the size of 2. So I'm going to use this right triangle to find this hypotenuse. So I'm going to work over here on the side here, and we're going to find BC. So which will be our c squared for this one. And then what we're going to do is we're going to use a distance formula, or we could use Pythagorean theorem, couldn't we? We don't really need to use a distance formula here. So we could say 2 squared plus 3 squared equals c squared. I'm going to use simplification here. And I'm going to add that 4 plus 9, and I'm going to get 13. My last step is to take the square root of both sides. So I find out that c is the square root of 13. Now, once again, if I needed to find out what that was to the nearest tenth, I would go back and put it into my calculator, and I would find out that the square root of 13 is approximately 3 and 61/100ths. So now I have that triangle. Now I have another triangle in here hiding. To get this third length here, I have this triangle right there, and there's another right triangle. So it has a side measurement of 2 and a side measurement of 1. So I'm going to use, in order to find this one here, AB, I'm going to use the Pythagorean theorem once again. So I'll have 1 squared plus 2 squared equals c squared. 1 plus 4 equals c squared. That's going to give me 5. And then I'm going to take the square root of both sides to ultimately find how much c is. And I find out that c is the square root of 5. Now, I do need to take that as the calculator and to find out to the nearest hundredth. And when I do that, I find out that that measurement of AB is 2 and 24/100ths. So you can see how we use the theorem to find right triangles that exist when we can't find other measurements. Or this doesn't happen. This happens to be a scalene triangle. So we couldn't use it directly with this. We could have also, besides using the Pythagorean theorem, we could have just used the distance formula and plugging in these points and finding those distances as well. So that's the other way to go about it. So there's various ways that we can use the Pythagorean theorem on a graph, and also using the distance formula. So hopefully you'll find this video helpful.